Hello, Andrew here again. I'm standing in the raw material yard here at the Haas factory, and you can see we've got literally tons of raw metal stock sitting on these racks here. Aluminum, brass, mild steel, harder steel, there's lots to choose from. In this video, we want to give you a quick introduction to the process of taking a raw length of material like one of these here and turning it into something like this, a finished part where all the machining has been completed. This is very typical of the manufacturing process you'll find at work in machine shops all over the world. So let's go on a quick journey as we turn raw stock into a finished part. When you're first starting out as a CNC machinist, many of these steps will be handled by your supervisor, a more senior machinist, or another member of your team. But we're laying them out here so you have an idea of what the process entails beginning to end. Now, these lengths of bar stock don't just magically appear here. There are many steps needed before these bars get to these racks. But this isn't a material purchasing and logistics video. We're here to talk about how the operators and machinists in a typical shop will be handling and working on these raw materials. So we'll start at the point where the raw material is moved from storage to where the work will commence. We'll look at a number of different parts here in the Haas machine shop as we follow what would be a typical manufacturing process in most shops. Let's say we're making a rectangular part. That means, of course, we'll most likely be starting with rectangular bar stock. The bars are moved by forklift onto the feed tables and then fed into this bandsaw. There they'll be cut into the short lengths we'll need for machining. When the order quantity is cut, they're barcoded to add them to the inventory system. If you're in a smaller job shop, these may just be hand counted and moved to the machine that will be machining them. Here at this CNC mill, the operator has the shop router, which is like the order sheet for the parts. And he also has the engineering drawing of the part, which shows the geometry and dimensions that define the shape and important aspects of the part. As a CNC machine operator, this is what you need to get started. This, and of course the batch of raw material you'll be machining. The operator will usually start by making sure the part number on the route sheet, the print, and the box of parts are all the same. They'll also quickly note whether the raw material looks like the right shape for the part they're making. A quick check with a tape measure can tell us if we've got the right material if there is any question. Now here is a machine that has already been set up by the supervisor. When we say the machine has been set up, we mean the machine is prepared to make a particular part. This is a little bit like baking a cake. Before you start, you need the recipe, the ingredients, the baking pan, some utensils, and the oven you'll be using to do the baking. On this basic milling job, the setup involves mounting this vise to the table, aligning the vise to the motion of the machine, and then tightening it down so it doesn't move as we machine the parts. The next part of the setup is what we call a part stop. This arm and the metal stopping point are used to locate the raw blank each time a new one is loaded into the machine. Since the stop doesn't move, each new blank is loaded in the same position every time. This is one of the simplest kinds of part stops, and there are countless other ways to do it. So we know how we're going to locate our workpiece, but the setup isn't done yet. Next, the setup machinist will gather the tools needed for the job. Once these are gathered, they're loaded into the machine. Next, we need to tell the machine exactly how far each tool sticks out from the spindle. Once the machine knows this, it knows precisely where it should move to cut with that tool. Luckily on this machine, we have what's called a probing system. The machine touches each tool against this probe tip mounted on the table here and accurately records the position of the tool tip. We call this the tool probe. Now, even though the vise and the part stop have been set correctly in place, we still need to tell the machine where the workpiece is compared to the machine home position. The probing system on this machine also has what we call a work probe. The setup machinist will use this probe to touch off or find the faces of the workpiece as it's clamped in the vise. Once we've found the workpiece position one time, we're done. since the part stop should always locate the workpiece in the same place each time a new one is loaded. These tool and work offsets can also be set in a more manual way if a probing system isn't installed on the machine. It's a little slower and often not as accurate, but it achieves the same goal. In simple terms, now you could say the machine knows where the workpiece is and it knows where the tools are, all compared to its own home position. We're almost ready to go now. We just need a CNC program to tell the machine where and when to move while machining the part. The supervisor will usually load the program from a USB stick or a network location. The machine will typically be connected to the shop's computer network either by an Ethernet cable or via Wi-Fi, just like your laptop at home would connect to your home's Wi-Fi network. Once the program is loaded, it can be selected to run and will appear here on screen. Often there will be a note in the comments section following the program number, which will match the part number and description on the part drawing. Finally, it's time to get started making parts. Load the part. Keep it square. Reference the part stop, and tighten the vise efficiently. The operator will watch the first part carefully as it gets machined. Do the tools sound like they're working correctly? No shrieks or howls, no big vibrations or chatter. If the operator notices anything that doesn't sound or look right, they'll likely press feed hold and get their supervisor. We'll look more closely at these steps in later episodes. Here are a few of the typical tools you'll see cutting metal inside CNC machines on a daily basis in most machine shops. The face mill. These larger diameter milling cutters are designed to make the top face of the workpiece very flat and prepare it for further machining. The end mill. There are so many different types and variations of end mills that we won't attempt to cover them all here. We will dive a little deeper into the different kinds later, but for now, this end mill here is quite typical and is used to profile and shape the workpiece as it removes material. The drill. Everyone is probably familiar with drilling. These metal cutting drills work very similarly to those designed to cut wood. And drills are the most efficient way to make holes in your part. The tap. Anywhere you need to thread a screw into your part, you're going to need threads to screw into. Taps are the cutting tools that make the threads and always start with a drilled hole before they can do their part to cut the thread. Let's look at some of the features we machined on our raw steel blank. We cut the part very flat and at the correct height using the face mill. We profiled the outside edges of the block and added counterbores using end mill cutters. We drilled holes of various sizes, some partway into the block and some all the way through, and some in preparation for tapping threads. Finally, we tapped some of those drilled holes to add the threads called out on the drawing. So there's a quick sample of some of the tools we used to machine this raw blank into a finished part. When the part is complete, the operator opens the doors and then the vise. He pulls out the part and blows it off and the vise off with compressed air, making sure all the chips are clean from the vice's locating surfaces. And there you go. We took a raw length of material, cut it to size, loaded it in our machine, pressed cycle start, and minutes later, after all the tools did their part of the job, voila, we have a finished part. Now the real benefits of the CNC machine come into play. In other words, we can keep making this same part one after the other until we've made as many as we need. Now the operator grabs the next blank and loads it up in the vise, making sure that it's square and located properly and sufficiently tight in the vise. He closes the door and hits cycle start. Now he can measure the part that was just finished to check that it's in tolerance. The operator will work his way over the part, checking the critical dimensions using the correct measuring tools. If he finds any measurements that are outside of tolerance, he'll set the part to the side on the table so he can check it again with his supervisor and not lose track of it by putting it in the box with the finished good parts. And if the operator does find a part that's out of specification, they will stop the machine after the next part is complete. so whatever problem is causing the part to be out of spec can be fixed. If this machine was running a very complex, difficult, or very long runtime part, then each part might be inspected before the next one was loaded. Sometimes the machine might even be stopped partway through the program to have measurements taken, to make sure there aren't any issues that need to be corrected. As long as the parts are coming out of the machine in spec, then the operator runs the job until the required quantity of parts is completed. Sometimes this will be the entire batch of material that was delivered. Sometimes it will only be part of that quantity. Some shops run short quantities of many parts, and some shops run larger quantities of fewer parts. Your supervisor will let you know what the lot size is you'll be running. With this run of parts complete, it's time to load another job onto this machine, or move to a different machine to work on another part. Thanks for watching, and we'll see you in the next video.